All right, let's dive right in. Today, we're tackling two fundamental concepts in C programming that, let's be honest, can be a little confusing: structs and unions. By the time we're done here, you'll know exactly what they are, how they're different, and when to use each one.
So let's kick things off with a problem every single programmer runs into. You've got a bunch of different pieces of data, but they're all related to one single thing. How in the world do you keep them all bundled together? Imagine you're coding a video game. You've got a player, right? That player has a name, which is text. They've got a score, that's a number. And they have health, maybe a decimal point value. They're all different kinds of data, but they all describe your one player. We need a container for that.
And the most straightforward go-to answer for this in C is the structure, or as you'll always see it, struct. So what is a struct, really? Well, think of it as a custom data container that you get to design yourself. It's a way to package up all those different pieces of information under one single, easy-to-remember name. And here's what it actually looks like in code. I mean, look how simple that is. You just use the keyword struct, you give your new data type a name, and then, bam, you just list all the variables you want to group together inside those curly braces. It's that easy. This right here is the absolute key. A struct is an AND box. It holds everything all at once. It's just like a business card. It has dedicated space for a name and a title and a phone number. All the information exists together, simultaneously.
Okay, that makes sense. But what if your problem's a little different? What if you don't actually need to store everything all at once? What if you only need to store one of many possible things at a time?
And that, my friends, is where the union comes into play. It's a pretty special data type, and it's all about efficiency. You can define a bunch of different members it could hold, but the catch is it only actually holds the value for one of them at any given moment. Now, take a look at this. The syntax looks almost exactly the same as a struct, doesn't it? You just swap out the keyword struct for union. But don't let that fool you. How this thing works under the hood is a total game changer. I love this analogy because it nails the concept. A union is an OR box. It's like one of those reversible signs in a shop window. You can flip it to show open, or you can flip it to show closed. You can never, ever show both messages at the same time. It's one or the other. And that brings us to the real aha moment. This is the single biggest, most important difference between structs and unions, how they use your computer's memory. So like we said, a struct holds everything at once. And to do that, it has to set aside enough memory for every single member, one after the other. Its total size is just the sum of all its parts. Pretty straightforward. So for our example struct, you just do the math. The character array needs 20 bytes, the integer needs 4, and the float needs 4. You add them all up, and you get a total of 28 bytes. Easy. The union, though, is way craftier. It's all about saving space. It looks at all the members you've defined, finds the one that needs the most room, and then only allocates enough memory for that single largest member. Everybody else just has to share that same space. So in our union, the character array is the big one at 20 bytes. That means the entire union is only 20 bytes big. That integer and that float, they just borrow that same 20 byte space whenever it's their turn. That's a pretty significant memory saving.
But, and this is a huge but, that shared memory comes with a serious risk. Let's say you store the integer 10 in the union. Great. But then in the very next line, you store a float. Well, you've just overwritten that exact same piece of memory. If you try to go back and read the integer, you're not going to get 10. You're going to get complete garbage because those bits now represent a floating point number.
All right, let's put these two side by side in a final showdown. This should make the choice between them absolutely crystal clear. This table really just lays it all out. When it comes to memory, structs add everything up. Unions just take the size of the biggest member. For storing values, structs hold everything. Unions hold just one at a time. And for access, you can grab any data you want from a struct anytime. But with a union, you better be sure you're asking for the last thing you put in there. Okay, so you see the trade-offs. Now for the most important part, when do you actually use which one in your own code? It really just boils down to this. Use a struct for AND situations. Think of an employee record. You need the ID and the name and the salary all available at once.
Use a union for or situations. Think of a data packet that could contain an integer ID or a string message, but never both. It's perfect for those cases, especially when every single byte of memory counts. And that leaves us with one final thought to chew on for your next project. You know, with modern computers having just massive amounts of RAM, is the clever memory-saving trick of a union still worth the very real risk of creating those nasty, hard-to-find bugs? Something to think about.